My name is Dana Ellis. I'm a Senior Program Manager at the National Center of Manufacturing Sciences. I'm currently working on a very important project, a collaboration project under a program sponsored by the Office of Secretary of Defense, the Commercial Technology Maintenance Activities Program. The CTMA program, Commercial Technology Maintenance Activities, is a collaboration effort between the Department of Defense and the National Center of Manufacturing Sciences and its member companies to reduce total ownership costs and sustainment costs. Under a collaboration agreement between NCMS, Universal Synaptics, and Organic Maintenance Activities who co-sponsor technology development, we are able to deploy new technology to DoD maintenance activities real time. The CTMA effort expansion of Intermittent Fault Detection and Isolation System, IFDIS, at Ogden Air Logistics Center for the F-16 Central Air Data Computer, CADC. The CADC has a high no-fault found rate attributed primarily to undetected, undiagnosed intermittent faults. The IFDIS is an advanced engineering diagnostic tool designed to detect and isolate intermittent faults by monitoring every circuit path simultaneously and continuously to detection of intermittent faults. This is a quantum leap in the diagnostic capability that fills the gap with single circuit scanning and single sampling testing void that exists today with the joint services that are challenged by detecting and isolating faults in aircraft wiring, avionics, and LRUs. Currently, wiring integrity issues is a $2 billion problem for the Department of Defense and affects the operational readiness of our warfighters today. The IFDIS is a proven technology that has increased material readiness and has reduced the cost associated with no fault found and unscheduled maintenance. The advanced capabilities of IFDIS are an important element to the overall DoD maintenance strategy to reduce costs. By partnering with NCMS, Organic DoD maintenance activities, we are able to quickly assess these no-fault found and maintenance challenges by working directly in their facilities, working side by side with industry to solve these complex problems in real time right now today.
As Dana mentioned, this particular CTMA project with the IFDIS is the expansion of IFDIS capability to be able to test the F-16 Central Air Data Computer. You can see that the first thing that we do is remove all of the active electronics. Once all the active electronics are removed, we build form-fit replica interface test adapters so we get the right pressure, the right fit, the right alignment, and you can see that we are literally and physically connected to every single circuit within this chassis, including the external connections. The first test that we run is a continuity test. Go ahead, Tony, and let's fire this up. So no different than conventional test equipment, the IFDIS at this point is scanning one circuit at a time, checking simply for nominal value and to make sure that the ohmic readings are such that we don't have a wide open circuit. The other thing this test does for us is it validates for us that our interface test adapter is connected up properly to the unit under test. So this test is now complete. You can see that this box checks clean. There are no open circuits. The next test we'll run is shorts, which again is a conventional type test, one circuit at a time. So again, you can see that the IFDIS is scanning each circuit individually, one at a time. And just like the continuity test, you can see that this box passes. There are no shorts. So we have no opens and no shorts. This is the extent of conventional testing that's going on inside the depots and maintenance activities that support these depots. For all intents and purposes, this box is good. It's checked clean. It's going to be installed on an aircraft. What we do is we take it a step further and test every single circuit all at the same time. So let's go ahead and get into intermittence mode. So in intermittence mode, we are monitoring every single circuit individually, simultaneously and continuously. That gives us 100% probability, and then we're also super sensitive, detecting momentary discontinuities into the nanosecond range. So right now, sitting in its ambient condition, this box has no intermittence. Tony, let's turn on the shaker. So what we're going to do now is induce some vibration. So very light vibration at this point, similar to taxiing on a runway. Go ahead and turn it on. So you can see with minor vibration, we've already got several intermittents that are showing. With just a minor vibration, we've got several intermittent circuits inside this chassis. These are the faults that continue to occur as no fault found, and these are the faults that continue to give the pilot problems when he's in the air. This box comes in, it's tested for continuity, which you saw it pass. It's tested for shorts, which you saw it pass. These boxes continue to cycle through these depots, incurring tremendous cost and technician frustration. The ability to monitor every single circuit individually, simultaneously and continuously eliminates the random nature of intermittence. Intermittence appears to be a random problem because other technology and equipment can only measure or test one circuit at a time. We've eliminated that. While other testers are virtually blind to this phenomenon, we see everything. We're taking a massive chunk out of NFF costs and unscheduled maintenance.